This is the worked answers to the Unit 6 test, question 2. So immediately our eye is drawn to this equation. This is a negative quadratic, so it's making a U shape. That's just something I pick up immediately. So the height of the tennis ball above ground could be modelled using that equation, where H is the height and X is the horizontal meters. Find the height the tennis ball is struck. Find the height after 7 meters. So what I'm going to do is I'm going to draw this tennis ball. So the tennis ball, we have our X and Y axes. In fact, this time it's an X axis and a height axis. The constant is 1.7 and it's a negative quadratic, so it's doing something like that. That's smudged. So when it is struck for part A, that tells me that X equals 0. So when X equals 0, H equals 1.7. And in fact, I'm going to add that to my diagram. When X equals 7 meters, so when it's gone 7 meters along, its height is the Y value. So all we need to do is substitute in to the equation. So H equals 1.7 plus 0.18 lots of 7 minus 0.017 squared. If you type this into your calculator, you're going to get 2.47. So that's A and AI both done. In part B, they tell you that a ball is called in tennis and it must hit the ground before it travels 25 meters. So what I'm going to do is I'm going to substitute in 25 and see the height of it. So very similar to what I've just done for AI. So when X equals 25, H equals 1.7 plus 0.18. Lots of 25 minus 0.01 lots of 25 squared. And this gives me a height of 0.49. And then I realised a small problem is I know that it's a height of 0.49, so it's 49 centimetres off the floor after 25 metres, but it doesn't tell me whether it's hit the floor or not. So there are two possible scenarios. The ball has done one of two things. It could have hit and then bounced, so that at 25 metres this value is 0.49, or it could have not hit yet and at 25 metres I've got 0.49. And in each of these scenarios we have a different answer. This one is in, this one is out. So in fact, finding where it was after 25 metres wasn't useful. What I actually want to know is when does it hit the floor. So what I'm going to do instead of letting X equal 25, I'm going to say H equals 0. So 0 equals 1.7 plus 0.18 X minus 0.01 X squared. You should all have quadratic solvers on your calculator. So type in these values in, you should get an X1 of minus 6.84 and an X2 of 24.8. We are going to ignore this negative value because X is only positive because we're measuring it from the start. So this point here, in fact, is 24.8 meters. So the ball would have been in. In part C, it's asking you to change units. It's asking you to change from kilometers per minute to meters per second. So what I'm going to do is I'm going to multiply by some things. To work out what I'm multiplying by, I'm going to try and make that fraction equal to this fraction. So I'm going to times it by meters over kilometers. I'm going to times it by minutes over seconds. So this shows me that I need to, the kilometres will cancel, the minutes will cancel, leaving in meters over seconds. So if I do kilometres per minute times by 1 over 1000, so this fraction is actually 1, because 1 metre is equal to, hang on a minute, I've done that the wrong way round, 1000 metres is equal to 1 kilometre. And then doing the same with minutes to seconds, 1 minute over 60. So this tells me that I'm going to be timesing by 1000 and dividing by 60. So 2 times 1000 divided by 60. That will cancel out. So I end up with 100 over 3, which is 33.3, and that is going to be meters per second.